So please welcome Massimo.
Thank you very much. Thank you. Thank you. Hello, so good morning. Good morning. My name is Massimo Candela. I'm a principal engineer in the global IP network of NTT. And in particular, I work in a team that is dedicated to software development for the automation and monitoring of the network. So occasionally I did this presentation, usually internally to customer briefings, because I will show some behind the scene of how we manage the network at NTT. But for SwiNOG, I decided that it could be interesting also, and there are also some lessons learned, so I hope it's going to be useful. And we will talk, of course, about software, in particular software for the automation. So I would like to start with this definition about SDN. When we talk about software and network, are we talking about software-defined network? So software-defined networking, SDN, is an approach to networking that centralizes control of the network by separating the control logic to off-device compute resources, which is a complicated way of saying that essentially the control of the network is on an item that is outside the single device. But the important part is to understand the goal about this. And this enables operators to use a programmable control to orchestrate and automate network services. This is the key. This is what we want to achieve. This is what we talk also during this presentation. So really brief introduction about this. So the terms, the keyword SDN appeared around 2008 with the paper of OpenFlow, and it took some spotlight in 2012 when Google started talking about its own deployment and implementation of SDN, and there was this really, I think it's really great presentation that they did at the Open Networking Summit. And Google, being a big player and talking about this topic, of course, was able to put a spotlight on this topic. And of course, the OpenFlow part is a radical departure from the traditional networking. However, many of the problems that Google was presenting, that Google encountered during the deployment, were more about programmatic control of network devices. So imagine like you are in a context of cloud, for example. And if you are in a context of a cloud and you have, for example, a software as a service, and you want to make it scale between 3 cloud instances and 300 cloud instances, we are all well aware of technology, even multi-cloud solutions that they would allow you to do that. So it's not an impossible task, and your costs are, of course, going to grow between 3 and 300, but still it's a manageable growth that you have. Instead, this concept, especially at that time, but still as of today, they are not really applicable one-to-one to networking. So if you scale from 3 devices to 300 devices, your costs are going to grow, not only the cost of the device itself, but also the cost of the people that they have to manage these devices. And this is mostly because traditional networking is about devices that they are self-contained, and then you put it in the network, you have to configure it, and they go from there. So it would be nice to apply the same scalability, and I think scalability is a good term, that we are used with cloud to network. And the key concept on which the entire SDN topic brought light on are mostly about centralized and automated control of the network, and API-based control of the network and of the network elements, and abstracted data models to describe the network. This abstracted data models is also a key part, really important. So the fact to just see a device as a device, it doesn't matter the vendor or whatever, it's just a node of your network. Now, just to briefly, this is traditional networking. We all know each device has control plane, data plane. When we go to the pure definition of the SDN, we have that essentially we have not anymore, we have devices that have capability of SDN, where essentially the entire control plane is on outside controller, okay, in a centralized outside controller. This type of more, I would say, pure approach is an approach that in a way it had less uptake for obvious reasons, because there is, of course, you have to have these devices. They are capable, so you have an investment on the device, also investment in knowledge, and it will also make this cooperate with the rest of the network, and also at the same time, for most of the organization, it's not really clear what the benefits after this investment is to transition to a model like this. So the uptake was moderated. What instead most of the big players that they deploy SDN solution do, they do something that is called like hybrid SDN, and this is also what we do at NTT, which is essentially an approach where you can use your current infrastructure, or anyway devices that you are used to from your vendors, that they have control plane and data plane, but you have an outside controller, you have an outside component software that is able to coordinate and be able to orchestrate and deploy services across all these devices in a way that essentially you just plug a new device independent from the vendor, and whatever is just a node on which you expand. And this is mostly what we did and what we will focus today. So essentially what I would say here is that in this concept of hybrid SDN is essentially automation on steroids. And what do we do on the global IP network of NTT? So let's start by saying, what is the global IP network? Is a division of NTT Ltd. NTT Ltd is a giant company that has under more than 30 brands under its umbrella, services of all type, from data center, cloud, whatever. But the global IP network is essentially an IP backbone network. We are a tier one in various locations. We have more than 85% of the global 100 Fortune companies and stuff like this. But we operate on BGP with one autonomous system, which is 2914. And so NTT has been doing this process towards this automation on steroid. From now, let's just call it automation, on really many years ago, before I even had my first internet connection. So I'm talking about historical stuff mostly. And the idea was that management already identified many years ago that, of course, IP transit pricing are going down every time. And so also the underlying cost of managing your infrastructure has to be kept under control. And they identified automation as a key factor on keeping this cost under control. It does require an initial investment, but it was going to repay later on. And it reduces costs by, for example, minimizing peer review. This is just an example. And there are stories about policies of many years ago of NTT where each configuration of the network that was going to be applied required a peer review of at least 4 people, which is, when I heard it, it was crazy. But you have to consider that we are originally a Japanese company, so this puts things under perspective. But so, and also lower staff requirements. So it doesn't mean that people will not have anything to do anymore. That's never the case. But that you can manage the growth of your staff in a fashion that is like more contained and clearly not linear with the expansion of the network, in a way that you can keep running the business and be and running a successful business. And of course, what this provides overall is higher quality of service, mostly because software is in place. Software is really good in doing repetitive tasks, and a lower error rate. You are always going to have errors, independently if what software and blah, blah, blah. But much lower error rate, especially compared to manual configuration and stuff like this. And especially low catastrophic one. And if there is any error, you patch it, and then that specific error is not going to happen again. And of course, at the same time, you improve service delivery. And this is also an important key factor. So for example, for consistency, And this was one of the main reasons that started this entire thing. What we wanted to be able to do is to be able to move a customer from one port to another, or from router to another, from one port to another, and deliver the same configuration or deliver the same service independently from the vendor used and stuff like this, and to do that without downtime. And for doing that, you need, of course, this type of automation. And you have to consider that it's an important factor for us to be multi-vendor, and we have a policy where we have, in whatever moment, at least 3 vendors on our network. This is, we have more than those, but at least 3 we have to always have it, and this is related to do not have lock-in with specific vendors, or also to do not be related to specific market situation and stuff like this. And at the same time, also deliver fast speed of more agile in delivering services, because of course you have software doing that. And we brought this to the extreme. I will show you something, especially in the last 5 years, we did this really more and more. Of course, all of this comes with extensive network visibility, because now you have software and APIs, and you know what's going on in the network. So let's talk about what we are really doing inside NTT. So our system is called the GIN, where GIN is Global IP Network Management System. The acronym is GAMS. The name could have been better, I'm sorry. It's a software that is developed in-house, and it started development in the 90s at a company called Verio, which after it became NTT, became part of NTT. So this software has more than 20 years of development, and it is not a software that it just new feature, improvement, and stuff like this over more than 20 years. And these things started way earlier than most of the theory and concept that they are available at the moment, way earlier, for example, of the SDN definitions that I was talking before, and was originally developed by, and as I told you, it was identified as a key factor to keep the business successful. A small investment that was going to pay on the long run. And there was it was not a bunch of scripts that people start developing, but there was a cohesive idea and a cohesive effort from management to actually develop this software. Originally, it was mostly developed by the network engineers, by IP engineers themselves. It currently manages more than 500 devices. It's fully automated but not autonomous, so it's always human triggered, and this is by design. And now this is developed by a dedicated team, which is the team that I am part of. And this is a team that is more software-oriented in a way that we can make this in a way better and free also the IP engineers from developing. Now the system. This is the platform. The idea behind it. This is there is a central database, which is the single source of truth, and there is of course a UI that you can change things in the database. If there is a device in the network, this device has the configuration in the database. The database is where everything is stored. And of course, and there is also M4 and M4 macros. That part, you can clearly see that this is 90s part. And as I don't focus on that part, because this is the starting part. I'm going to show you also the deployment, the development. So yes, there is a 90s technology, but has been working as a charm for a lot of years, and allow us to be flexible and to be really ahead of time in all network-related configuration. So what happens is then essentially configuration is in the database. All the configuration on the routers is generated on the server side, and after is pushed on the routers. And this happens with something that is called brute force configuration deployment, where essentially this device configuration generated on the server is pushed on the router, and there is a software called Rancid, which sets this configuration on the devices and also monitors the devices for any change. So the IP engineers, they are able to access the device. because they always should be able to do it for emergency and whatever, but they should not in general do that. And whatever change they do is going to be reverted to what the database has as information. When we developed this many, many years ago, there was not the support from many vendors, and we had to explain our use case, and some of the commands that now are used to do that were developed at that time for us with our use case, and now they are commonly available. Now, what we did is that we essentially moved from knowing router commands to essentially database table. But in particular, we were able to achieve that kind of multi-vendor platform where we are able to abstract the network, abstract the devices, and just configure the network with what we want and deploy that configuration. Now, and this was important for us, and we still not handle gracefully, for example, concurrent configuration. So if I change an interface and some of my colleague changes another one, and clicks deploy, is going to deploy my stuff as well. That is a problem. We still had to click through thousands of pages to configure network configurations that they are moderately complex. And then you can see what I mean. We like, for example, for an interface, you have create, move, config and stuff, and maybe you have to do multiple interfaces, a lot of clicking. So, evolution of this, after improving this software and developing it, and it's still super great software, we decided it was about time to rewrite it from scratch. And so 5 years ago, we started with this GAMS evolution. So the architecture is similar. As you can see, we removed, there is PyConfig tool template, now it's generated with Python. There are Jinja2 templates and stuff like this. But there is also an API that is the gate to the database, and there is a new UI, and there is a lot going on between these two. And the reason for that is because we moved from what before were essentially tables to service-based provisioning. So essentially, now we don't describe anymore interface and device and stuff like this, but we move more towards the description on an entire service. And that is allow us to abstract even more, and we are able to do entire configurations in single pages, less clicks, less moving around. Configurations are atomic. So there is no more the possibility that I save something that gets deployed in the middle by somebody else. And the entire configuration is essentially done by a UI that is a client that has domain logic about stuff and is able to allow us to describe the service and validate the service after it's sent to the API that does the testing, the validation, and whatever, and it's persisted. If anything fails, the entire service is essentially rolled back and nothing is written. So I want just to give you a practical example, also to see what does it look like or what we do. This is really a behind the scene. So imagine that this is optical configuration. We do an optical configuration. So we go in this page, we start typing a device that exists in the system. There is autocomplete and whatever. Then we select the device, boom, and we see the device in this single page. And we have a device, optical device. They have shelves, they have slot, sub-slot, ports, links, and all of this is in this hierarchical view that you see on the left. So you can see the entire device and all the subcomponents. You can see the hierarchy that it has, and you have access to all of them. And if you click on each one of these, you see the information configuration on the right side. Okay, so it's visually more simple. You don't have to move around between pages and stuff. And you see the most important field, the one most used. And in advance, you can see all the other field. If you change stuff, you save, and all of this gets saved at once. And you can load multiple devices, so you can do a configuration that involves, for example, 3 devices, all in one single configuration, all in one page. There is even a tab that shows you, one of the panels that shows you exactly what you created. This is a single device, but if you have multiple devices, you can also see the layout of how they are interconnected to each other. And if you click on well, this is a link, and just to show you the system is able to automatically check in real time what you are doing, and it tells you, for example, oh, this link is involved in a service. Before to delete or do anything, you have to change or deactivate or move the service somewhere else. So it does prevent a lot of things already from the UI point of view. Now, however, if you are in this type of system and you want to create a new device, then you will have to add, for example, a new device, a new shelf, slot and stuff like this. So even in this case, for a new device, you would have to click some time to create the subcomponents. So we, as I said, we even put this to go even faster. So we boosted even more, and basically we created what we call topologies, which are essentially templates of templates. So let's call it like this. So basically, if we know that we have configurations that they are common, which they can involve one device or multiple devices, we can pre-configure that, and we can load them with one click. So we can create a new device, for example, an L100 with this topology, and boom, this is a device that doesn't exist, but automatically has been pre-populated with shelves, 3 shelves in this case, ports, slots, and whatever. All default values automatically set, MTU values and everything calculated and stuff. And the only thing that the UI is telling you is that, well, now you have to give me the IP address and stuff like this. And once you provide these fields that are in red, you can save this new configuration. And basically, it does drastically reduce the amount of interaction that you have to do this and to start a new service. Now, my presentation is basically over, and I want to share some generic lesson learned that over these many years. So the first thing is, especially from an historical point of view, has been heavily reported that there is a buy-in that has to be done. So the organization has to be, in a way, convinced to adopt most of this solution. Network engineering teams, they sometimes have this attitude of the network wizard guy that does everything in the CLI. I don't want to have all this stuff. So they have to adopt a bit on the dev culture. Some employees may feel that they are going to be scared, but I think this was something most of the past. I don't think today is the case. To be automated out of job is not the case. I really do not know any organization that has the exact amount of work. Most organizations have a backlog of stuff. So in general, it's just a way to get this backlog processed faster. Also, our team constantly grew over the year. It's not that people are automated out of the job. It does require an investment also because it will need a dedicated team to develop this solution. It cannot be done on a spare time of other stuff. You will have custom development. There is no solution that is just out of the box works independently from you buy or build. There will be custom development. But anyway, I would say it's important to start somewhere. And you don't have to do all at once, so it doesn't have to be perfect. You can start with a specific service that it brings a lot of values in your company, and you start automating that. Also, you have to be aware about what is called skill rot, which is essentially, through automation, you can deliver and deploy services more easily, but still you need the people that they really know and they really understand what's going on the routers, because things can break, and those are the people that in the end can fix for real what's going on. And also those are the people that they can tell to the other team, the software engineering team, what really has to be done, and that has so you have to keep an eye on not losing your real low-level network skills. So my presentation is over, and these are my contacts, and I'm going to stay here for the entire evening, and if you have any question, please let me know. I don't know if we have time for questions.
Any questions?
Thank you.
Thank you very much. Okay.
Thanks. That was an interesting presentation. I have one question. I take it that this software that you wrote here is proprietary in terms of its internal. Have you ever considered open sourcing it and gaining a community around it?
I don't think, okay, this is not a question that I can answer directly, but I would say I don't think it's going to be open source. It actually is difficult to open source a big investment like this and more than 20 years out of it. I mean, I don't think it's, we open source a lot of things. For example, Rancid is open source. We have a lot of monitoring, for example, BGP Alerted that we develop and we open source. But open source requires a lot of effort. Not only there is a lot of expectation, even if it's free, there is a lot of public expectation and stuff. And this is for sure a big commitment to open source. And it's also a big advantage in a way for us. So I don't think it's going to be open source.
Thanks, also from me, very nice. On this last point of the skill rot, do you have like maybe 1 or 2 tips how you address this problem?
Okay, what I would say is that in the end, so basically if you take, I don't know, somebody that is not really in our field with the solution that I presented and some explanation can probably deploy a server. But if anything would break, that there is no way that really. So you need to maintain the network engine because they are the one that they actually have the knowledge of how things work and also are the one that they really provide this information to the developers. And when you are introduced, for example, a new platform, they are the one that they understand how this new platform communicates with. And in reality, this essentially frees them from repetitive tasks and allows them to focus on tasks that they are more on the architecture side and that they are more on the added value side, or even to be more, for example, available to interact with customers directly. One of the things that we did is our customer service, we removed layer 1 support, so we basically, we have more capability to directly answer to customers with network engineers directly. So this is a way to, add value.
Any more questions? Okay, I have one. Do you know Oxidized? And why are you still like developing on Rancid? And could you maybe think that Oxidized could need some love?
It's a good question. So I give you the straight answer. The thing is that so the developer of Rancid was also part of the team up to a few months ago, and that part of the infrastructure really works as a charm. And we started developing this many, many years ago, and of this entire restructuring, that last part, so between the config and the devices, is the only part that remains the same also in the old system. We don't have a real pressing motivation to actually change it because it does exactly the brute force configuration and the monitoring configuration that we really need. And at the moment, we don't have a business case to actually go there and just replace. There are other solutions that can be used, netconf as well and stuff. But we didn't have really a case to really do this move because the system that we have for us works really well at the moment. And also is something that we already had. So you have to put it, if you would start from scratch completely now, of course, we would adopt other solutions. But this is something that developed in more than 20 years. So if you don't have to change a specific part, why doing it in a way?
Thank you, and thank you very much, Massimo.
Thank you.